Lecture number 7, control section and transition. Control section is mean the section that we normally know the depth of the flow. For the case of the rapid flow or the supercritical flow are controlled by upstream condition, so computation of the subsurface profile must be started at the upstream end of the channel. In case of the tranquil flow or the subcritical flow, affected by a small change in the downstream condition, so the computation must start at the downstream end of the ridge. Okay. The control section occur at the entrance exit change in the channel slope. At the gate is a channel in a channel can be controlled for the both upstream and downstream ridge. Okay. Control section in the figure below figure. A for A is flow pass through a critical at the entrance to the channel. Entrance is can be this one. It can be some reservoir. To the channel, and in this case, if the channel is steep, okay, so it means the computation process downstream. So in this case, we expect to see this passing as YC. But in case of the mild slope, this case is steep slope. In case of mild slope, this point, the entrance is equal to YC, normal depth, or Y naught. Okay. And part B, a change in a channel slope from mild to steep, passing through a critical at the break in the grade. Computation process both upstream and downstream from the control section. This is B. And for C, a gate in horizontal channel, control both upstream and downstream. Okay. And this figure is similar to previous lecture, similar to classify the name of the water surface profile. Just combine together in one figure. Okay, for example, for this one, for the mild slope. The mild slope, if the water surface is above normal depth, we call M1. In between normal depth and YC, we call M2, and below YC, we call M3. Okay. And below figure hydraulic jumps, as this figure 7-2, resulting profile consists of the piece of the H2 and H3, that is a H2 and H3. In the computation, this profile for the unknown discharge H3 curve is computed starting at the gate. Okay, contraction coefficient must be known and proceed upstream, downstream. So it means direction of the flow. We proceed this way. Until the depth will reach the YC. So it means we can calculate like this. Another curve, H2 curve, is computed starting with YC. We start from this point at the end of the channel and proceeds upstream. So in this direction we proceed this way. depth conjugate to this along H3 and compute as shown. So you can see that the depth that is the depth conjugate to the HT is like this one, thing like this. The intersection of the conjugate depth curve and H2 curve locate the position of the jumps. Okay, and if H2 curve is everywhere greater than the depth of conjugate to H3, it means it's a draw jump. Okay, occur with H2 is extend to the gate. So it's like if curve like this. Okay. In H2 everywhere, so it's a draw jumps. Okay.